Hi everyone, so we'll be solving this question today. Let's have a look at it. Okay, so from the question it says that it's given to you an equation of motion, and as you know we're in SHM, so this is an equation of motion of a simple harmonic motion. This is the equation, and they say that x is in cm. Okay, so we call this equation of motion because if you input a specific time, what will come out is the displacement of that particle from the equilibrium position. This is called the displacement from equilibrium position. Okay, so if you input a specific moment, input a specific time, what will come out is the displacement from equilibrium position. We call this the equation motion. Okay, so when we receive an equation motion, it's important for us to be able to extract information from this equation of motion. Okay, so let's practice it here right now. The equation is x equals to 5 sine 3t. Okay, this is our equation, and to extract the information, we compare the equation with the general formula. Okay, so this is the general formula for equation of motion for SHM. It's a sine omega t. Okay, so if you see here, what we can do is we compare these two equations, and we can know that a is equals to 5, whereas omega is equals to 3. Okay, so if you may recall from your classes, A will be representing the amplitude. So the amplitude is 5, and since they state it clearly, the displacement is in cm, so it's A equals to 5 cm, amplitude equals to 5 cm. So that's the maximum displacement the particle can have from the equilibrium position. Okay, we can also extract out omega equals to 3. Now you are not sure about the unit. What should you do? First thing, if it's inside a sine, cos, or tangent, it should be in radian mode. Okay, it should be in radian. Okay, so the time is what we might be a little bit concerned about, but if you see here, they describe everything in terms of second. So it's safe for us to say that it's 3 radian per second. Okay, so the next thing we can do is to proceed with the question. Okay, it's important for us to be able to extract the information from the equation. So means by you need to be able to know how to go from here to here. You need to know how to go from here to here. Okay, so knowing that, we are able to continue and solve this question. Question A. What is the amplitude? The amplitude, as we have determined just now, it's 5 cm. B. The period of oscillation. Period of oscillation is big T. Okay, as you might see here, there's no big T symbol in the equation of motion just now. So, but don't worry. Okay, if you are freaking out, don't worry. What you can recall is, if you have omega, actually it's equivalent to you having period or frequency already. Okay, they carry the same information, just in different way of representing it. That's why you are able to convert between these quantities using this specific formula. Omega equals to 2 pi f if you want to convert from angular velocity to frequency. T is equals to 1 over f if you want to convert from period to frequency or vice versa. And omega is equals to 2 pi over big T. Okay, 2 pi over big T if you want to convert between angular velocity and period. Knowing that these three things represent the same information, we call it temporal information, but I'll just write it time. Okay, so knowing that these three things are different way of representing the same thing, we can just convert between them. Okay, we know that we will require this formula, omega equals to 2 pi over big T. So what we can do after that is just rearrange this equation in the form that we need. Substitution, and there you go, the answer for B. Okay, next thing, question C. Question C say its displacement at time equals to 0.2 seconds. Okay, means by it's asking for a displacement at a specific moment. Okay, just now if you can recall, I said that equation motion, you input a specific time, what comes out is the displacement. So this is what are we going to do right now. We input the time as 0.2 seconds. So to be more careful, we write at t equals to 0.2 seconds, x is equals to 5 sine 3, we sub in t as 0.2 seconds. So if you calculate everything, the result that you will get is 2.82 cm. If you're worried about it, you want to write it in meter, feel free to do so. Okay, so very straightforward. That is the displacement at time equals to 0.2 seconds. Let's continue. Question D. Question D asks for the maximum velocity, which is denoted with symbol V subscript max. Okay, you might be able to recall from formula that is equals to plus minus A omega. Okay, so we have A, we have omega, everything should be quite straightforward right now. It's a matter of substitution. Okay, so you may write in 5 and 3 inside, then what you may come up with is 15 cm per second. If you feel like wanting to convert it into meter, feel free to do so. Okay, so again, you might be wondering, Vmax, its maximum value, why can it accept negative value? It's plus minus. Why is it so? Okay, it's a little bit tricky to answer this question, but basically we're just asking for what value can you achieve? What's the maximum value of velocity that can achieve? And as you know, when the thing is oscillating, it may oscillate up and down. Okay, let me draw it to illustrate it more clearly. Okay, so let's say this is your ball or particle oscillating up and down across. As time passes, it's oscillating. Okay, so it's oscillating. So the maximum velocity, I presume the maximum velocity will be at the equilibrium position. Okay, this is what we may learn from theory. The thing is, this will be the velocity maximum, but at this particular moment, the velocity maximum is going up. But for this particular moment, the velocity maximum is going down. Okay, and it's going up for this moment. So it's natural that we will have positive and negative value for our maximum velocity, because the velocity can happen in both directions, either upwards or downwards, or if it's a horizontal oscillation, then it's leftwards and rightwards. Okay, so next thing is E. E asks for maximum acceleration again, it's probably something you can recall from the formula. It's plus minus a omega square. A omega square, the value is still similar like just now, so it's a matter of substitution, but this time with a square. So what you may get is 45 cm per second square. Okay, be careful with the units. Again, you may convert it to any units you prefer. I prefer the SI units, so this is my conversion. Okay, again there's plus and there's minus. Okay, so yeah, since we talk about Amax, let's see why Amax there's positive and negative. Okay, imagine this is your particle oscillating again. So if you are at the maximum displacement from the equilibrium position, at this point you have your restoring force will be maximum. Your restoring force will be maximum, and therefore you have your acceleration, which is in the same direction as the force. Okay, force is equals to ma. That's why if F max is going downwards, A max should be going downwards as well. Okay, F equals to ma. It's not F equals to negative ma. If it's F equals to negative ma, then they are in opposite direction. But F equals to ma, that means F and A are in the same direction. For this specific position here, you may see that the restoring force is trying to pull the particle back upwards towards the equilibrium position. So F max here will be upwards. And again, since it's F equals to ma, therefore your acceleration will also be upwards. Okay, so in this case, the A max here will be positive, but A max here will be negative. Okay, so there's possibility for the maximum acceleration to be positive or negative, depending on the position of the particle itself. Okay, question number F. Question number F asks for the velocity when its displacement is 4 cm. Okay, it asks for the velocity when the displacement is 4 cm. Okay, so this question will require a formula that you might have just learned about it. So the formula is V equals to plus minus omega square root a square minus x square. Okay, the a is amplitude as usual, whereas x is the particle displacement. We want to find the velocity when the particle is at a particular displacement. There's too many particles here. Okay, don't worry. Okay, so we are finding velocity, so it's a matter of substitution again. 3 5 cm minus the displacement. They ask for displacement when it's 4 cm, so we substitute 4 cm into the equation. Okay, so what will come out will be 9 plus minus 9 cm per second, or you can convert it to meter as well, 0.09 meter per second. Okay, so now we want to explain this particular thing. Why is there a positive negative sign here again? Why, when you are in a particular position, when you are at a particular displacement from the equilibrium position, you can have positive velocity or negative velocity? Let's look back at this same exact diagram. Okay, the diagram is a bit messy, but bear with me. Okay, so let's say you want to find the velocity when the displacement is let's say for this case 4 cm. Okay, so we want to find the velocity when the displacement is 4 cm. Okay, so you can see the particle is at this particular displacement at this moment and this moment. Okay, these are two different moments. These are not two different balls. Okay, I want to be very clear, so I draw an arrow here and I say this as time passes. As time passes, the ball is oscillating like this, and at two particular moments that we see here, two particular moments, the displacement is 4 cm. Let's look at the velocity then. For this one, the particle at this moment is going upwards. The velocity at this particular moment is going upwards. Whereas for this moment, the velocity of the particle is going downwards towards the equilibrium position. So downwards. Okay. So for this case, this will be a positive velocity, whereas this will be a negative velocity. That's why even though you are having a very specific displacement, you can have velocity in positive or negative direction. Depends on which particular moment you are in. So it's okay for us to leave a positive negative sign here. Okay, so last question, question G. Okay, I don't have a lot of space, so I'll probably move it down a bit. Okay, so I'll sketch G here then. Sketch the graph of displacement against time. Okay, so the displacement against time, so we can safely assume that this is x. You want it to be in cm, that's fine, no worries. Time in second. It's important that we label the axis label and the unit, just like what you do in the experiment. Okay, label this as 0, just a form of practice. So this is the thing that you are going to plot. This equation, you are going to plot this. Okay, so how I usually plot this, I see what trigonometric is this. It's sine. So you know that it will be a sine graph. It's positive. There's no negative sign in front, so it's a positive sine graph. So feel free to sketch a sine graph. Okay. If you want to double it, that'll be great as well. Okay. So after that, you can label two things. The two important things to label is, first thing is your amplitude. You need to label this, and the next thing is you need to label the period. Two important things to label. Do we have an amplitude? Yes, it's 5 cm. Easy, just write 5 here. Okay. It's also common practice that we label both sides. So this will be -5. Okay, so next thing we plot is, next thing that we label is the time, the period. The period, we have already determined it to be 2.09 seconds. Okay, so now it's a matter of labeling it inside the diagram. Okay, labeling these two things, and you have completed the displacement against time graph. Okay, so we have progressed through from question A to question G just from a single equation of motion. For me, my advice is you have to be very clear how to extract information from the equation of motion. How to do it? By comparing it with the general formula, which is x is equals to a sine omega t. Again, if you are able to obtain omega already, it's equivalent to you already obtaining omega, period, and frequency. Obtaining just one of it is equivalent to obtaining everything already. You just need to manipulate it using these formulas here. Okay, so and oh, again, you are dealing with chapter 9, so it's in radian mode, so your calculator should be in radian mode as well. Okay, so when you're dealing with maximum velocity and at maximum acceleration, remember that there's plus minus sign in front to indicate the possibility of moving in both directions. Okay, so these are the things to be careful of. So that's all for question 1. Thank you.